Okay, class. Oh man, you're killing me, Smalls. Okay, let's try this again. Pretend like you want to be here. Pretend like you're excited. Pretend like you enjoy this class, because if you had someone else, they would be super boring, right? So appreciate it. So class. Yes. That's better. Now, do me a favor. Everyone, please take out your phone, because we're going to have a slight issue here. Just turn it off and put it away. Just turn it off and put it away. Now, there are some people with this, it's called this obsessive compulsive phone disorder. No matter what, every couple of minutes, you can actually watch other people in other classes. They're not getting anything. They're not getting any messages or stuff. They just have to check it. It's actually a response where they're not even getting any notices or something on their phone. They just always have to pick up their phone and look at it. It is obsessive compulsive disorder. So yes, the was it Journal of Psychological Health or something like that, and behavior. Yeah, they came out with it. It adds a compulsion. So it is a type of OCD. So you always want to pick up your phone. And I always want to yell at people for having earbuds in instead of listening to me. But I would not call on anyone in particular for that. So what we're doing today is normal distributions. Normal. This is going to be super important. The normal distribution, this is my bell shape. And empirical rule, 80, 68, 95, 99.7. So I will go over this in great detail. There we go. Okay, here it is. Normal distributions. You have this written on your notes, right? Yes? Yes. So, a normal is a bell shape. Does it have to be symmetrical? Okay. It says graph a normal distribution called normal curve. Curve is bell shaped and symmetric about the mean. So it doesn't have to be perfectly bell shaped, because if you notice, look right here, it's not symmetrical completely. So if you look right here, this one is different size than this one. If I'm looking at all the different sizes as I'm going off from here, they're not all the same sizes. So it's not perfectly symmetrical, but it looks pretty close, right? That's the reason why that this bell curve here, fits. Everything fits under that. Does that make sense? Yes? Nonsense? Sense or nonsense? Jay Quellen? Okay. That was a nod from Jay Quellen for those people watching. All right, so it says right here, the area under the curve, normal curve, is 100%. So all the data here, this represents 100% of the data. And we're going to talk about just portions of this now. We're going to start talking about just portions of this. So it says right here, histogram of vocabulary score 7th grader students. Smooth curve shows overall shape of the distribution. That's my red line right here. That's showing the smooth shape. And normal distribution. Okay, using two numbers. Okay, standard deviation of a normal curve. Mean, center of the graph. So the mean. Now, on our calculator, what's the special notation for my calculator for the mean? When you're looking for the mean, what is the little thing on the left you look for? What's it look like? Go ahead. Do that again. What is it? Perfect. That's it. That's all we're looking for, right? So that's going to be x with the line on top, which is referred to as x bar. Now, it's also this symbol right here. The mathematical notation is this symbol. It is a Greek letter, and the letter is mu. Like the Pokemon, Mew. Okay? That is mu. Standard deviation is quantity that you're moving from the mean. So, standard deviation on my calculator, what do I have? What am I looking for when I'm looking for standard deviation? I heard it? There it goes. S x, right? Standard deviation on the calculator is xx. Now, it also, the symbol for the notation, which you will see mathematically, if you ever look up something in, like, Google it, because you're trying to figure out what this is, or getting help from for your homework for whatever reason, if you look this up, standard deviation is going to give you this symbol right here, which is mu and sigma. Sorry, sigma. That one is sigma. It's like a capital Q flipped upside down. That's what sigma is. And this one is mu. Okay, just like the Pokemon. Alright? So, okay, when the mean and the standard deviation are not specified, we use the standard normal curve, which has a mean at 0, standard deviation of 1. And I will show you that here momentarily. So I'm going to start at 0, and then my standard deviation is going to be 1 that way, 1 to the right, and as we go. I will get there here in a minute. Actually, let me actually show that here. So here's where it's at 0. This is what it was referring to. At 0, 0 is my mean, right here. 0 is the mean, so that's going to be right down there. And then the standard deviation, since it isn't measured, it's just 1. So that means, what is the distance from here to here? You would say 1. And it's the same distance for all of them. From here to the next one is also 1. Here to the third is going to be 1. Same thing goes in the other direction. That's how wide these are. Standard deviation means the difference in between my mean and my first number here. Now I'm going back to here. Empirical rule. The total area under a curve is 100%. As a decimal, it's 1.0. 68% is within 1 standard deviation of the mean. 95%, 99.7. Now, I'm going to explain this on the next page, so you could go through and fill this one out. Is this one, yours isn't filled out, is it? No, it's not. Okay, so you're going to fill this one out, and we're going to do this together. So, right here, this, right here in the center, is referred to as my mean. Okay, here's a mean. Oh man, that is horrible. Okay, let me try that again. And I am going to notate it. There's my mu. 1 standard deviation this way. That's what this 1 right here means. 1 standard deviation this way is going to be 30%, 34% of all the data. 34% of all the data is this way. So think about the mean. The mean is the average, so that's everything that we have. So majority is going to be right in here. My next one is going in the other direction, which is also 1 standard deviation. 1 standard deviation is going to put me here to here. So this is also 34%. So now in total, 1 standard deviation, how much of my data is 1 standard deviation? What do you think it's going to be? To the left, it's how much? 34%. To the right, how much? So in between 1 and -1 is how much? 68%. So 68% of all my data should be right there. Does that make sense or nonsense? Does anyone need further explaining on here? Ariel? You okay? You falling asleep back there? You know, I got a bunch of empty space up here if you want to come up here. You sure? I didn't need to know that. You didn't need to announce to people, okay? I was just asking if, you know, you could see better up here. So, next one. One more standard deviation puts me right here at 2 standard deviations. So the distance from here to here is going to be 13.5%. So here to here is 13.5%. So same thing going the other direction is also another 13.5%. And that's taking me to right there. So in between all of it from 2 standard deviations, what is the total percentage I'm going to have for 2 standard deviations? 95%. Since I'm adding 68, and then I'm adding 13.5 and 13.5, which is 27. So 68 plus 27, which I'm adding to these, is going to be 95% from here all the way that way. 95% within 2. So that means almost all my data is going to fall in between here. So the majority of my data is going to be right there. Questions? All right, let's keep going. Let's go to my next standard deviation, which is right here. And this is my 3rd standard deviation, which is going to be my 2.35%. Same thing goes on the other one. And that's going to put my inside from here 3 standard deviations all the way to here is going to be my 99.7%. So 99.7% of all my data is going to land in here. So let's pretend like I like to gamble. Because I really don't like to gamble, I don't. I'm going to have a dice. Okay, I'm going to shoot 1 die. Okay, I'm going to throw 1 die. What this is saying is, with that 1 die, the high percentage is that I can actually get a number from 1 to 5. So the majority of my data, I think it comes out to like 86% of all my chances to throw 1 die and get a number 1 through 5. So it's a high chance, right? So if you're shooting craps with someone, then that is a high percentage chance that you could actually get that. And Adiel trying to go back to sleep again for some reason, right? Yeah. So that's what we're trying to do here by finding percentages for certain things. Now, I know I'm boring you guys to death, so do me a favor. Please don't fall asleep on me. You can go get a drink of water or something? Okay, go get a drink of water. Now, this last one. So above the 3 is going to be my 0.15%. 0.15%. So that is a very, very small percentage. A very, very small percentage of this. So less than 1% is going to be out here plus 3. Same thing over here. So everything else is going to be way over there. So whatever my bell curve goes out to, it's going to go all the way out this way. It's going to go all the way out that way. But almost all your data is going to fall within all this right here. Now, this is going to make more sense when we actually apply it to one of the word problems here. Actually, I think I have the wrong thing. Ah, yes, I do. I have the wrong one. 1 second. And I'm gonna grab this other slide. That's the worksheet. Student notes, there it is. Now, this first example, so let's see right here. So this first example says right here, it says SAT scores are close to a normal distribution. So normal distribution refers to what shape? A bell. Okay, commonly referred to bell curve or just bell. With a mean at 500. So if the mean is 500, where does the 500 go? Right in the middle, right? Directly right in the middle. Right here is going to be 500. With the mean of 500 and a standard deviation of 100. So what does that mean that these lines breaking this up are standard deviations? So what's this next number here? Why is it 600? Why is it 600? Standard deviation says that it's going up by 100, right? So this is going to be 600. The next one is 700. Last one is 800. All right, let's go down now. So below 500 is?
400.
Below that? 300. And below that? There we go. 200, right? Gotta say it like that. Gotta be gangsta. Yeah. 150. Yeah, 50. Yeah. Anyway. All right. And so let's see. What percent of scores are above 700? What percent of scores are above 700? So what I'm going to do is I'm going to look. 700 starts here and goes this way, right? So if this is my mean, so this is my mu, and then this is plus 1, this one is plus 2, right? Say yes. So that's my plus 2, right? So I'm going to do some neat stuff here. If the mean represents half the data, right? Mean represents half the data. So from the mean going this way is what percent? Yeah, it's 50. So that I'm trying to make this easy. So mean going down is 50%. So we're going to add up the pieces. So that's 50% right there, right? And what did we say one standard deviation going this way was? What percent? From the mean to this way was what percent? 34. 68 is the whole thing in between both those. But this piece right here by itself is 34. So that's 34%. And now going from here to here, what percentage was that?
95.
Not 95. Not 95. Hold on that one. This was what?
13.
Okay, 13.5. So, we want to eventually figure out what this blue one is. I don't know what the blue one is yet, because it's only part of this. I just went from 700 this way. Can I figure out all this over here? Say yes. So I could do what with all my percentages? No, not double them. Let's add them all together. Because it's going to give me from right here all the way this way. That's what I'm looking for. Add it up because I'm looking for everything up to here, which is going to give me 50 plus 34 is 84, plus 13.5 is 97.5. Yes? So we're going to have all this is 97.5%. But now, what is the whole curve? What percentage? 100%, right? The whole curve is 100%. So what would I do to find out just a little blue piece? Take it away from 100, right? So I'm going to do 100 minus 97.5, which is going to give me 2.5% is just this piece down here. Yeah. Does that make sense? Usually this is probably the easiest way to do this one. There's another way, and I'm going to show you that one here in a second by doing this exact same thing over. I'm going to do this exact same one over again, but I'm going to show you using the other way. So from the last one that we just did, oh, it is this one right here. So plus 2. So from my plus 2 to the right, this was 2.35%, right? Yes? That's this little piece right here, 2.35%. But now this one over here, which I'm also going to add, because my third standard deviation is going to be 0.15%. So plus 0.15%. As long as we don't fall asleep right now, we might actually be able to, I see you there, okay, add these up and we should get 2.50%. So that's another way of doing it if you know the percentage for every piece here. So we can look at it like that also. So if we know each percentage, we can just say, hey, this one here is 2.35. The next one is going to be 1.5. Or I'm sorry, 0.15. Sorry. So that's another way of doing it. But understanding that your half of it here is supposed to be 50%. From the mu down is 50%. Right? So we're going to need that information later on anyway. Now let's take a look at example 2. It says the scale of scores on an IQ test is approximately normal with a mean of 100, standard deviation of 15. All right, I'm going to start with that. I'm going to start with just that piece right here. So given that right there, what am I going to label this first thing as? What am I going to label this right here? 100. So right here, this is going to be 100. Now, standard deviation says I do what? 15, right? So what do? I go to the right. I go to the right how much? 15. And what value do I find there? 115. And so this is going to be my plus 1. This is my mu. And my plus 2 is going to be what? 130. Very good. And right here at plus 3 is going to be 145. Now let's do the minuses. My standard deviation going to the left. What are we going to have right here? We're going to have 85. So I could tell what standard deviation some people should fall on this scale. Because if I told them to take their phone and put it away, and they still can't seem to do that because their phone keeps going to their hand for some reason, they're going to be on the lower end of the scale over here. So this is minus 1 here. Now, Here's those people that can't seem to keep their phone away, which is at how much?
Oh no, that's 70.
70. So down here, okay, those people that can't seem to keep that phone away, that's why the phone's got to go away, not on the desk. And my -3, 85. There we go. Now that we went through and drew this, we went and filled in everything that we need, right? We filled out everything we need. Let's see. It said the organization Mensa, which is calling itself the High IQ Society, requires an IQ score of 130 or higher for membership. Now, anyone know what IQ actually is? Kinda. Okay, so think of it like this. So if you think about this intelligence test right here, it's not doing good on Jeopardy. You know what Jeopardy, you guys know what that show is? Yeah, you go through and you answer a whole bunch of facts, right? That's referred to as static memory. Okay, that's static knowledge. It's stuff that is just in your brain and it stays there. So it's not a working process. It's not a problem-solving thing. IQ refers to a problem-solving intelligence. So you don't have to know basic things that a lot of people know. Now, okay, so there you go. On the charger now. Yes. Oh, yes, I have another one. It's right there in the back next to my coffee maker. So just set it on there. Now, okay, IQ refers to knowledge and problem-solving skills that, you don't actually need to know certain things, like historical facts. So since we just recently had a national holiday, let's see if you guys could actually, pull off some of your social studies knowledge. Okay, in what year did Columbus arrive in the New World? What did you say? You say 1425? 14? Down a little. Maybe. Anyone else? Your mom was born. Okay. Yeah. Your mom might be that old. Anyone else? What year did Columbus arrive at the New World? I'm not saying discover the New World. Oh, man, hell no. Put that thing away. That's the problem. There's things that you don't know. And that's static memory. That's things that your social studies teacher did not teach you, or stuff that, yeah. Okay. You guys remember? No? No? Come on.
We're not gonna remember.
1492. Okay.
What?
In 1492, Columbus sailed the ocean blue. That was a mnemonic to try to remember that. That is a static memory. That doesn't say I'm smart. That just says I remembered a fact. That is, yes, your mom? Are you sure? No, yeah.
My grandma.
Oh, I don't think so. Anyway, now, the IQ refers to a problem-solving skill. So let's say I give you a puzzle. You can solve that puzzle and within the time frame. That's what this is referring to. So IQ refers to that. So requires an IQ score of 130 or higher for membership. What percent of adults would not qualify for membership? Okay, so let's see. Let's go through and start labeling my percentages. So I want to know how much is not. So 130 is right here. So I want to know from here all the way down, right? I want to know all of that. So let's start with right here at the mean. From the mean down is how much? Very good. That's what I need here.
Oh my God.
50%, right? Now, what about this next one? 34%. And this one here? So now to figure out all of it, everyone from this point on would be what percent of adults would actually not qualify. So we just add all those up and we come up with 97.5. So not qualified, 97.5%. So only 2.5% of adults would qualify for this. Now, if you think you're one of those people, Mensa actually does have a website that has a practice test if you want to try it out. So it's just puzzles, problem solving type thing. So none of it's like static memory that you need to know, who is John Wilkes Booth. Candy, are you really rolling up one right now?
No.
Yeah, exactly. Yeah, instead of writing notes. Yeah, roll a doobie. Yeah, you're rolling a doobie. Anyway.
Hey, but come for look.
Go FERPA what? I'm looking at you with disdain right now. I am looking at you with disdain. So you guys are going to try example 3, write me out. You are doing 3, write me out. And yes, I see you're excited. You rolled up a joint during class. Oh my goodness, yeah. So everyone currently is filling in this one right now. Not looking at me awkwardly, filling this in. No, you do not need to enter all this data here. You just need to put it on your graph. Okay, so what is it going up by every time? What is it going up by every time? Okay, so now after you went up here to get what? 115. So after 115, what's that give you? 130, because why? You add another 15, right? And that's spacing. Because that's on the notes for the normal curves. That's what I had us write down. Where to go? 3, 4. Actually, 5. Looks good. Good. Let me see. I think so. Yeah. 3, 4, 5. All right, everyone should be about done right now with filling this in, not just drawing stuff on their paper, because that would just be super awkward to not use this time wisely and just doodle. Not saying that doodling is not a good thing. I'm just saying use the time wisely. All right, so first things first, mean. Where does the mean go? In the middle, and I know Deja's not playing with the phone, right? And the increments, this is going up by how much? 194. So that means this mark right here is going to be how much? 1705?
Yes, sir.
Very good. All right, next one is going to be 1898. 99. And my last one? 20 what?
93.
So there's my +1, +2, and +3. There's my mu. Next one is -1. What do we get for the -1? 1317. Next one. And last one. All right, so -2 and -3. All right. So we have everything filled out now. And it says, what is the point range in the middle 68%? Where's the bottom of the 68%? What is the point range of the middle 68%? Let's fill in our percentages then. So from here to here is 34, and here to here is
34. What's at the top?
So what is it going to be together? So the middle 68% starts where? 1317, and it goes to 1705. That is my range, and it's from 1317 and it goes to 1705. Now, what does that really say in the course of this data, Deja? Is zoning out? Okay. So, make sure you're up here. So, that says that 68% of all people that took the SAT scored between 1317 and 1705. That's what that means there. Does that make sense? Hopefully? Good. Next one. How high must a student score to be in the top 2.5%? Top 2.5%. So let's look. If I start inputting my percentages, that means it's going to be 68 to here, and from here to here is my 13.5. Next one is going to be 2.35.
Yeah.
And this last one is going to be 0.15. So I want top 2.5. So that means that from the top to 2.5 is actually going to be adding these two here. So from here over is going to be 2.35 plus 0.15, this is 2.5% by adding those two together. And so what score do they have to get to be able to be in the top 2.5%? 1899. Very good. So it's 1899 or higher, right? So 1899 or higher. All right. Any questions over that? Is that pretty simple here? So when we're doing the homework, you need to take a look at right here. So these things right here, so this is on the homework. It's referring to determine histogram indices normal distribution. Now, if we think about the notes that we just did, normal distribution is what? Say it. Say it. I heard you say it. What is a normal distribution? I heard it. Say it. Loud and clear. Bell. You know, y'all are wearing muzzles, so it's really hard, and just so you know, you guys actually have to speak loud enough for the mic here.
There's a mic?
Yeah. Yeah, I named it Mike. M-I-K-E. So my M-I-C is named M-I-K-E. So I got two turntables and a microphone over here too. Because it's where it's at. Got two turntables and a microphone. Anyway. Bell shape. Is this bell shape? Is this roughly bell shape? Yeah, it's roughly bell shape, right? So can I call this one a normal? Okay, sure. Because it's what shape? Thank you. Let's look at the next problem. Is this one right here going to be a normal? No. This one is not normal. ¿Por qué? Porque es tú not normal. I don't know. I'm trying. Come on. Huh? Yes, always. Yes, you're always high. Anyway, what shape is this one? I heard it. Skew. And to which way? Right. Very good. This is right skewed. Now, what shape does a normal have to have? A bell. Does this have a bell shape? No. So is this one normal? No, because what shape is this? Skew to the? Thank you. Bam. I just gave you the first two answers. All right. Go forth and do your homework.